Cayley-Hamilton theorem. The statement is, every square matrix satisfies its own characteristic equation. So this is the statement of Cayley-Hamilton theorem. And now the application of Cayley-Hamilton theorem is to calculate the positive integral power of the matrix and the inverse of non-singular matrix. So these two are application of Cayley-Hamilton theorem. Okay, the first problem based on the Cayley-Hamilton theorem. Verify Cayley-Hamilton theorem for the matrix A is equal to 2, minus 1, 2, minus 1, 2, minus 1, 1, minus 1, 2. Hence, find A inverse and A power 4. So first we have to verify the Cayley-Hamilton theorem for the given matrix, and then we have to find out A inverse, A power 4 using Cayley-Hamilton theorem. We do not find A inverse by using the formula A inverse equal to 1 by determinant A into adjoint A. You do not use the formula. We have to find out A inverse using Cayley-Hamilton theorem, and also we have to find out A power 4 using Cayley-Hamilton theorem. So first we have to verify Cayley-Hamilton theorem for the given matrix. So for that, first we know the statement of Cayley-Hamilton theorem. Every matrix A satisfies its own characteristic equation. So that's first I want to find out characteristic equation of the given matrix A. So now the given matrix is 3 by 3 matrix. So we know the characteristic equation of the 3 by 3 matrix, which is lambda cube minus s1 lambda square plus s2 lambda minus 3 equal to 0, where s1 is sum of the main diagonal. So the diagonal elements are 2, 2, 2. So that sum of these two is 6. And s2 is sum of the minors of the diagonal. So what are the diagonal element? First 2, whose minor is neglect the column, neglect the row. So 2 minus 1 minus 1 2, which is first one. And next minor is second element is 2. So minor of the 2 is, so leave the first in the column and leave the row and leave the column. The remaining element 2 2 1 2. So which is the second term. And the minor of the third element is 2, which is eliminate the column and eliminate the row. 2 minus 1 minus 1 2, which is this. Now simplify this. So 2 into 2 4. 4 minus of my minus. So this is minus of minus plus. Already one minus formula. So minus 1. So 4 minus 2, 4 minus 1. So this is 3, this is 2, this is 3. 6 plus 2 is 8. So S2 is 8. And S3 is determinant of the matrix. So you know the determinant, first one plus, minus, plus. So 2 into 4 minus 1. So this is 2 into 4 minus 1. And the second term we want to choose minus, minus of minus plus. So 1 into minus 2 plus 1. So 1 into minus 2 plus 1. And plus 2 into 1 minus 2. So 2 into 1 minus 2. So simplify this, you will be getting 3. So now we found S3 also. Substituting these three values in here. So S1 is 6, S2 is 8, S3 is 3. So substitute these three values here. We will get the characteristic equation. Lambda cube into S1 is 6, so minus 6 lambda square, plus S2 is 8 lambda, minus S3 is 3, so minus 3. So this is the characteristic equation. The characteristic equation is lambda cube minus 6 lambda square plus 8 lambda minus 3 equal to 0. Take equation number 1. So this is the characteristic equation of the given matrix A. So by Cayley-Hamilton theorem, it satisfies capital A. So by Cayley-Hamilton theorem, A satisfies 1. So that for lambda put A. So for lambda put A, so A cube minus 6A square plus 8A minus 3 into I, because I is the identity matrix, it can be written as 3I equal to 0. Take this as equation number 2. But the question is, we have to verify the Cayley-Hamilton theorem. For the verification, we have to verify it. So this is to be verified. So now to verify this equation, I want to find out A cube a square, but we have a, it is given. And you know I. What is I? It is a identity matrix 1 0 0 0 1 0 0 0 1. So we don't know, we have to find out a square and a cube. First I am going to find a square. You know how to find a square. A square is multiplication of a into a. So a matrix into a matrix, multiply these two matrix, already you know. So by multiplication of these two matrix, you will be getting this. This is called a square. Similarly, next I am going to find out a cube. So a cube is, this is a cube. A cube is a square into a. So now a square into a, multiplication of these two is, you will be getting the matrix this, which is the a cube. So after obtaining a square and a cube, I am going to verify the second equation. So that substituting these values in equation number 2. So this is the equation number 2. Here I am going to substitute a cube value, a square value, everything. So now substitute here. So a cube, which is a cube, substitute here. Minus 6 into a square. So this is a square. Plus 8 into a. So plus 8 into a. Minus 3 into I. Now you simplify. If you get 0, then it is verified. Cayley-Hamilton theorem verified. So now this is a cube. I am taking a cube and multiply minus 6 inside. So minus 6 into 7, 42, minus 42, minus 6 into minus 6 plus 36. So multiply minus 6 inside and multiply 8 inside here. Multiply minus 3 inside here, and now I am going to add these all the values. You see 29 minus 42, 16 minus 3. Add all the value, first term becomes 0. Similarly in the second term minus 28 and 38. You see minus 28, 36, minus 8 and 0. Add the second element, you will be getting 0. Similarly add each element, you will be getting 0 matrix like this. So after adding, if you are getting 0 matrix, then Cayley-Hamilton theorem verified. So first part over, Cayley-Hamilton theorem verified. Next the question is, we have to find out A inverse and A power 4 using Cayley-Hamilton theorem. So now I am going to find A inverse. To find A inverse, we have to take the second equation. This is the second equation, already we found it. So using this, I am going to find A inverse. To find A inverse, first we have to pre-multiply A inverse on both sides. So pre-multiply A inverse on both sides. You will be getting A inverse into A cube is A square. A inverse into A square A. A into A inverse, you see, A into A inverse is equal to I generally. So that A inverse into A is I, and I into A inverse is A inverse, which is equal to 0, because 0 into A inverse 0. So now from this I am going to find A inverse. Here we have A inverse. So A inverse I am going to separate. So when you take 3A inverse here, positive 3A inverse is equal to A square minus 6A plus 8I. So now to find A inverse, I am going to substitute A square value, A value, I value here. So now I am going to substitute the value A square. This is A square value, this is A value, this is I. So now to find A inverse, I am going to multiply minus 6 inside and multiply 8 inside. After simplifying these three matrix, you will be getting this. This is 3A inverse. Take 3 right hand side. So now 1 by 3 is equal to the matrix, which is A inverse. So this is the A inverse of the given matrix using Cayley-Hamilton theorem. You do not use direct formula, because the question is we have to find out A inverse using Cayley-Hamilton theorem. So second part also over. Next we are going to find A power 4. The A power 4 also we have to use using Cayley-Hamilton theorem. So now I am going to find A inverse using Cayley-Hamilton theorem. Again I am going to take the second equation. From the second equation, I am going to multiply A on both sides. So multiply A on both sides. This is A cube into A power 4, A square into A cube, A into A square, I into A is A. I want A power 4, so keep A power 4 in the left hand side, take all other term in the right hand side. So now minus 6A cube is 6A cube plus 6A cube, plus 8a square is taken as minus 8a square, minus 3a you take it plus 3a. So now I am going to substitute a cube value, a square value, a value here. So now this is the term, 6 into a cube term, minus 8 into a square term, plus 3 into a term. Now you simplify these three matrices after multiplying 6 inside, minus 8 inside, 3 inside. Simplify, you will be getting this. This is a power 4. So now we found a power 4 using Cayley-Hamilton theorem. So third part also over.